Hi, welcome to the third number patterns tutorial titled The Second Difference. Today's tutorial is a fairly involved tutorial, so I need you to pay careful attention, and most of the work will be worked examples. In terms of what you need to know to progress on with this tutorial, you need to have gone through the first two number patterns tutorials. You also need to have gone through the section in algebra called simultaneous equations. Now we are going to look at second difference. Let us start by looking at the series that goes 3, 8, 16, 27. This doesn't seem to follow any logical progression. 3 to 8, the difference there is 5. 8 to 16 has a difference of 8. 16 to 27 has a difference of 11. But look at this here. 5 to 8, the difference is 3. 8 till 11, the difference is 3. That means that the next difference, if I go with the next difference of 3, 11 plus 3 is 14. That means that the next term in this series is going to be 27 plus 14, which is equal to 41. This here is called second difference. It's fairly similar to an arithmetic pattern, except its standard form is Tn is equal to an squared plus bn plus c. It's a quadratic difference. Now we need to find the general form Tn is equal to. Hence we need to find our a, b and c values. The way I'm going to do that is by doing simultaneous equations. I'm going to start off by saying that my second difference 2a is equal to 3. That means that a is equal to 3 over 2, and that is the easiest part of this question. A is equal to 3 over 2. That means that Tn is equal to 3 over 2 n squared plus bn plus c. But term 1 is 3. That means that T1 is equal to 3. 1 squared is 1. That means that here b plus c is equal to 3 minus 3 over 2. 3 minus 3 over 2 is the same as 6 over 2 minus 3 over 2. 6 minus 3 is 3 over our common denominator of 2. That means that b plus c is equal to 3 over 2, and that is equation 1. To get our second equation, just take that away. To get our second equation, we're going to say that term 2, which is equal to a n squared plus b n plus c, term 2 is equal to 8. 2 squared is 4 times 3 is 12 over 2. 12 over 2, which is equal to 6, plus b times 2 is 2b plus c is equal to 8. That means that 2b plus c is equal to 8 minus 6. 8 minus 6 is equal to 2. So b plus c is equal to 3 over 2, and 2b plus c is equal to 2. That means that in this case c is equal to 2 minus 2b. All I've done is taken that across, substitute that into there. We're then going to be left with b plus, instead of c we have 2 minus 2b is equal to 3 over 2. I'm going to multiply out that 2. That means that 2b plus 4 minus 4b is equal to 3. 2b minus 4b is minus 2b is equal to 3 minus 4, which is minus 1. That means that b is equal to positive 1 over 2. If b is equal to positive 1 over 2, substitute that in there. That means that c is equal to 2 minus 2 times 1 over 2. 2 times a half is 1. 2 minus 1 is equal to 1. That means our c value is 1, our b value is 1 over 2, and our a value is 3 over 2. That means that an squared is the same as 3 over 2n squared plus a half n plus c, which is plus 1. Does that hold true? Let us take a look at it. The next term here, if I use the next difference of 3, that means that the next addition I'm going to do is 17. 17 plus 41 is 58. That means that the sixth term is 58. Let us look at that. T6 is equal to 3 over 2 6 squared plus a half times 6 plus 1. 3 over 2 times 6 squared. 6 squared is 36. 36 times 3 over 2. 36 divided by 2 is 18. Multiplied by 3 is going to give me 54, I think. Let's just have a look at it. 36 multiplied by 3 divided by 2 is 54. That's correct. A half times 6, so that's going to be plus 3 plus 1 is equal to 54 plus 3, which is 57, plus 1, which is 58. Yay, that's what we're looking for. Quick recap of this. Step 1, we found our a value. The way we found our a value was we said our second difference is equal to 3. That means that 2a is equal to 3. That means that a is equal to 3 over 2. We then did simultaneous equations, knowing that our second term, our first term was 3. That means that a, which we have n squared plus bn plus c, has to equal 3 when n is equal to 1. And when n is equal to 2, it has to equal 8. That gave us two equations. We solved it simultaneously to give us a, b, and c values. The one I gave you to do read 6, 11, 18. First thing, determine the next two terms. Now let's look at it. The first difference here is 5. Between 11 and 18 the difference is 7. That means that my second difference is 2. 7 plus 2 is 9. 9 plus 18, or rather 18 plus 9, is going to give me 27. That means my next difference is going to be 11. 27 plus 11 is going to equal 38. Alright, that means that my second difference is 2. I'm trying to get it in the form Tn is equal to an squared plus bn plus c. I know that my second difference is equal to 2. That means that a is equal to 1. That means that my standard form reads Tn is equal to 1 an squared. So that's just n squared plus bn plus c. But my first term, when n is equal to 1, my first term is equal to 6. That means that 1 squared plus b plus c is equal to 6. b plus c is equal to 6. Oh, sorry, 6 minus 1, which is 5. That's term 1. Term 2 is going to equal 1 multiplied by 2 squared plus bn, or b times 2, plus c, and that has to equal 11. 2 squared is 4 times 1 is 4, plus 2b plus c is equal to 11. That means that c is equal to 11 minus 4, which is 7, minus 2b. I'm now going to substitute that into that. That means that b plus c, or rather b plus 7 minus 2b, is equal to 5. b minus 2b is equal to minus b is equal to 5 minus 7. 5 minus 7 is minus 2. That means that b is equal to positive 2. I can substitute that into either of these questions to get my c value. I'm going to substitute it in there. That means that c is going to equal 7 minus 2b, or minus 2 times 2, which is equal to 7 minus 4, which is 3. That means my standard formula reads Tn is equal to a, which is 1, n squared, plus b, which is 2, n, bn plus bn, plus c, which is plus 3. Let us see if that makes sense. 1, 2, 3, 4. Fifth term should be 38. T5 is going to equal 5 squared plus 2 times 5 plus 3, which is equal to 25. 5 times 2 is 10 plus 3. 25 plus 10 is 35 plus 3 is 38. And that's exactly what we're looking for. With this one, you always check, because there's a lot of room for error. And that brings us to the end of the third number patterns tutorial. Please go through the exercise that I've left for you in the workbook before progressing on to the next tutorial, where we look at application of sequences and series.